Welcome to Get Your FRQ On. This question is from 2021. It's question 3, and it is not calculator active. In the question stem, we have a toy company that produces spinning tops using a family of curves for the shape of the top. In part A of the question, we are asked to find the area of the region when the parameter in that function is set to 6. So c is equal to 6. So the family of functions is y equals c times x times the square root of 4 minus x squared. And if I replace c with 6, we have y equals 6x times the square root of 4 minus x squared. If I want to find the region and its area, I can integrate from 0 to 2 6x times the square root of 4 minus x squared dx. Given the way this integral is set up, using a u substitution would be highly recommended. Specifically, if u is equal to 4 minus x squared, du is negative 2x dx, and 6x dx would just be negative 3 times du, which allows me to rewrite the integral from 0 to 2 of 6x times the square root of 4 minus x squared dx as the integral from 4 to 0 of negative 3 u to the 1/2 du, which if I factor out the negative 3, that becomes 3 times the integral from 0 to 4 of u to the 1/2 du, which is just going to be 3 times 2/3 of u to the 3/2 evaluated between 4 and 0. If I evaluate that integral, we get 16 square inches for the area of the region, specifically when c is set to 6. In part B of the question, we are told that dy dx is equal to c times 4 minus 2x squared over the square root of 4 minus x squared. And we are asked to find the value of c when the radius is maximized at 1.2. All right, so using properties of derivatives, the maximum value should occur when the derivative is equal to 0. So if I set that equal to 0 and figure out what value or values of x this would be true for, maybe I can figure out a specific value of c that would get me there. All right, so this thing is going to equal 0, specifically when x is equal to the square root of 2. Given the realistic nature of the story problem, I don't think we have to consider x equals negative square root 2 because there's no part of the toy over there. So x is equal to the square root of 2. And if I substitute that in to the function that describes the radius, we have 1.2, which is the maximum radius, is c times the value of x I just found, which is square root of 2, times the square root of 4 minus x squared, but we know x is now the square root of 2. So the only variable left for us is the value of c, and if we simplify this and solve for c, we get c equals 0.6. In part C of the question, another toy has volume 2 pi. Find the value of c that produces that toy. So to do this, we're going to have to find what amounts to a formula for the volume of the toy for any value of c. All right, so the volume of the toy for any value of c would be pi times the integral from 0 to 2 of the radius function cx times the square root of 4 minus x squared dx. If I simplify this a bit, we get pi times the integral from 0 to 2 of c squared x squared times 4 minus x squared dx. I can factor out the c squared. It's a constant. There's no need to keep it inside the integral there. So we get c squared times pi times the integral from 0 to 2 of x squared times 4 minus x squared dx. All right, finding an antiderivative for this, we can multiply it out. That gets us 4x squared minus x to the 4th. Find an antiderivative for that. That's 4/3 x cubed minus 1/5 x to the 5th. I still have to multiply by c squared pi, and I'm interested in evaluating that between 2 and 0. right? So if I do that, right, I'm going to get most of it done, but I still have that pesky c squared to deal with. But it does simplify to 64c squared pi all over 15. Right, so that formula gives me the volume of the toy for any value of c that I choose. However, I need the one that specifically produces a toy whose volume is 2 pi, so I'm just going to set that expression equal to 2 pi and solve for c. C turns out to be the square root of 30 all over 8.